So in the last class we have seen about buck converter. In the case of buck converter, the output voltage will be less than input voltage, so it is a step down chopper. So in this class we are going to see about boost converter. So this boost converter is a device or a converting device that converts a low value of DC voltage to a higher value of DC voltage. It will convert a lower value of DC voltage to a higher value of DC voltage. That means it is a step up chopper. Okay, so this is the circuit for the boost converter. Here you can see source is there, then inductor is connected, then parallelly a switch is connected, then a freewheeling diode, then capacitor, then the load. Okay, so here the inductor will store the energy during turn on, and it will be discharging the stored energy during the turn off time. Okay, it will be charging during turn on time due to this Vs, and it will be discharging the stored energy when during turn off. Okay, and also the capacitor, main aim of this capacitor is to reduce the ripple output voltage. Okay, ripple in the output voltage. Okay, and the freewheeling diode is placed here. The main purpose of this freewheeling diode is to provide a discharging path during turn off for the inductor. Okay, inductor will be charged, and the during turn off time there should be a discharging path for the inductor, so that it can dissipate the what all the stored charge through the load. So for that purpose only this freewheeling diode is provided. Okay, so inductor stores energy during turn on of switch, and it will discharge during turn off. Capacitor reduce the ripple content in the output voltage. Then the freewheeling diode is used here. It provides discharging path to the inductor when switch is turned off. Okay, so when the switch is turned on, what will happen here? You can see when switch is turned on means this side it will be short circuited, so this diode will be a reverse bias, so equivalent circuit will be like this part only. Okay, so equivalent circuit will be looking like this. Your source is there, then inductor, then it will be circulating here, so inductor will be charging like this. So freewheeling diode will not conduct, so as the switch is short circuited here, inductor will charge linearly with the as the till the switch is turned on. Till the switch is turned on, the inductor will be charged. Okay, so equivalent circuit will be like this during turn on. So this is the graph regarding this boost converter. Here you can see turn on time, turn off time. Turn on time is dt, then the full cycle is t, then turn off, turn on, like this. Okay, so similarly what we have seen in buck converter, this is the IL minimum, this is the IL maximum. Inductor charging during turn on, and it will be discharging during turn off. What all the inductor, what all the charges present in inductor during turn on, it will be discharging during the turn off time. So inductor will be charging and discharging between IL minimum and IL maximum. Okay, that is shown here. And the inductor voltage, okay, initially inductor voltage will be Vs. During turn on it will be Vs1. Okay, during turn off it will be, this part will be open circuited. During turn off it will be Vs minus V0. That is what shown here, inductor voltage. Okay, Vs and Vs minus V0. Okay, and because of short circuit, when switch is on, the supply voltage has no effect on load, as source and inductor is short circuited by the switch. Okay, when the switch is on, the the switch will be short circuited, and there won't be any relation between the supply voltage and the load, because current will not flow through that path. Current will be flowing through this path only, so there will be no relation between this source voltage and output voltage, load voltage, when the switch is on. That is what written here. And when switch is open, what will happen? The equivalent circuit will be looking like this. Inductor will be there, this freewheeling diode will be short circuited, and the charge across this inductor as well as this this input, it will be dissipating across this load. Okay, so source voltage as well as the inductor voltage will get dissipated across the load as the diode is forward bias. Diode forward bias means it will be short circuited, so the source voltage as well as inductor voltage will be dissipating across this load. So from 0 to dt, supply voltage has no effect on load, because this switch will be on, and the inductor will be charging in this direction only. So this source and this diode will be reverse bias, so this source and this output load will not be having any effect. Supply voltage has no effect on load. And from dt to t, supply voltage as well as inductor voltage will dissipate across the load. Okay, and when switch is on, what will happen? This is the equivalent circuit. Yes, it will be circulating in this path. Inductor IL, here it will be IC, then here it will be I0. Okay, this IL will not come in this part, because this diode will be reverse bias and also IL will be conducting here only. So when switch is on, when we are applying KVL, what will get? Minus Vs plus VL on equal to 0. Minus Vs plus VL on equal to 0. Okay, minus Vs plus VL on equal to 0, this path. So VL on we will get as Vs, VL on we will get as Vs. That is equation number 1. Then when we are applying KCL here this side no current is there. So if you are putting KCL here, what will get? No incoming current, outgoing current is IC on and IO. So IC on plus IO, which will be equal to 0 when we are applying KCL in this node. Okay, IC on plus I0, which will be equal to 0, that is IC on equal to minus of I0, that is equation number 2. And then when switch is off, the path will be, discharging path will be like this. Okay, it will be like this. When we are applying KVL here, minus Vs plus VL off, this is during off, VL off plus V0, which will be equal to 0. Minus Vs plus VL plus V0 equal to 0. Okay, when we are applying KVL, minus Vs plus VL plus V0, which will be equal to 0. Here minus plus, plus minus, plus minus. So minus Vs plus VL off plus V0 equal to 0. We will get VL off is equal to Vs minus V0, which is equation number 3. Then when we are applying KCL here, we are having one IL here, I0 here, then IC off here. So IC off will be equal to IL minus I0. IL minus I0. That is equation number 4. Okay. So 1, 2, 3, 4 we got. And from volt second balance, what it is stating? VL on into T on plus VL off into T off, which is equal to 0. VL on into T on plus VL off into T off, which is equal to 0. From 1 and 3, we will get VL on and V off. VL on is equal to Vs, VL off is equal to Vs minus V0. Substituting that here, VL on is Vs into dt. T on is equal to dt plus VL off is equal to Vs minus V0 into T off is 1 minus d into T, which is equal to 0. Cross multiplying, and finally we will get Vs equal to 1 minus d into V0, that is V0 equal to Vs divided by 1 minus d. V0 equal to Vs divided by 1 minus d. We know that the range of duty cycle is in between 0 and 1. 1 means in ideal case, otherwise duty cycle will be always less than 1. Means output voltage will be always greater than input voltage in this case. So that is why it is called as step up chopper. Here the voltage is boosting here, so it is called boost converter. So here output voltage is always greater than Vs, as V0 is equal to Vs into 1 minus t. So duty cycle will be ranging between 0, in between 0 and 1. So output voltage will be always greater than input voltage. So here the voltage is boosting. So it is called as boost converter, or it is a step up chopper. Input voltage is greater than output voltage, so step up chopper. Okay. Okay, so here we have seen volt second balance, and from ampere second balance it is IC on into T on plus IC off into T off, which will be equal to 0. IC on into T on plus IC off into T off, which will be equal to 0. From 2 and 4 we got IC on equal to minus I0. So minus I0 into dt plus, from 4 we get IC of is equal to IL minus I0. IL minus I0 into 1 minus d into t, which is equal to t of, we can written as 1 minus d into t, which is equal to 0. So solving this, we will get IL equal to I0 divided by 1 minus d. IL equal to I0 divided by 1 minus d. In the case of buck converter, what we got? Average value of inductor current, which is equal to load current. But in the case of boost converter, average value of the inductor current, which is equal to I0 divided by 1 minus d. Here in boost converter, load current and inductor current is not equal. Load current and inductor current is not equal. Okay. And it is depending on the duty cycle. Based on varying duty cycle, we can vary the inductor current. Okay. Understood? In case of buck converter, IL was equal to I0. Here IL equal to I0 divided by 1 minus d. In the case of buck converter, V0 equal to d into Vs. Here it is V0 equal to Vs divided by 1 minus d in case of boost converter. So it is a step up chopper, or it is boosting the voltage. So boost converter. And this one is ripple in inductor current. We have to find the ripple in inductor current del IL. Okay. We already know VL on is equal to Vs. Here we got VL on is equal to Vs. Okay. VL on is equal to Vs. Okay. And from figure 2, and from figure this figure, we can written as, here you can see inductor is charging from IL minimum to IL maximum. So there is a change in inductor current, that is from IL minimum to IL maximum, that is del IL. This is from time 0 to dt. Okay. And from dt to t, it is discharging from IL max to IL minimum. Okay. So that is what written here. So here this VL on is equal to Vs. VL on we can written as di on divided by dt. Di on divided by dt. The change in inductor current during on time is, change in inductor current during on time is IL minimum to IL maximum. IL minimum to IL maximum, that is del IL. For on time. On time means 0 to dt. Okay. So we can written as L into del I divided by dt. L into del I divided by dt, which is equal to Vs. So del I we get as d into Vs divided by FL. F means 1 by t. Okay. F means 1 by t. So del I we can written as d into Vs divided by FL. Okay. This is equation number 7. And also from that figure itself we can write IL maximum equal to IL average plus del IL by 2. IL minimum equal to IL average minus del IL by 2. In figure we get, this is the IL average. So this is total is del IL, this is del IL by 2, this is also del IL by 2. So IL average is equal to IL maximum, IL minimum is equal to IL average minus del IL by 2. IL maximum is equal to IL average plus del IL by 2. Okay. That is what written here. And next one is ripple in output voltage. Ripple in output voltage del Vc or del V0. Okay. So equivalent circuit during on we can see here. During on time you can see here. So here the capacitor, here what we can see here, the input source and load is having no effect. Okay, load is having no effect of this input source, because here it is short circuit and diode is reverse bias. So input supply voltage is having no effect at output load voltage. Okay. So here what will happen, the capacitor present here na, it will deliver power to this load. Okay. Capacitor present here will be delivering power to this load. So capacitor will deliver power to the load as the source is separated from load due to short circuit. Here short circuit path is there, switch is on. So the input voltage is not having any effect on load voltage. So here the capacitor will deliver power to the load in this case. Okay. So when we are applying KCL here, IC is equal to minus I naught. IC is equal to minus I naught. Okay. Means IC plus means incoming no current is there. Outgoing current is IC and I0, means IC plus I0 which will be equal to 0. That is IC will be equal to minus I naught. Okay. We know that IC can be written as C into dVc by dt. C into dVc by dt which is equal to I naught. dVc which will be equal to I0 divided by C into dt. I0 divided by C into dt. During on state, voltage across the capacitor is decreasing from Vmax to V minimum. From this figure, during off time, during on time, the voltage across the capacitor means from this figure also we will get during on time this source is not having any effect on load. So here the capacitor will be charged at that time. So it will be discharging from Vmax to V minimum. It will be discharging from Vmax to V minimum during on time. During on time means 0 to dt. So we will be integrating here from Vmax. Capacitor initial value of capacitor voltage is Vmax. Means it is discharging now. Correct. It is discharging during on time. This source and load source is having no effect on load. Here switch is on means 0 to dt. At that time to load capacitor will be delivering the power. So capacitor will be Vmax at initial time. It will be reducing to V minimum. Okay. So we'll be integrating the above equation, that is from integrating from Vmax to V minimum dVc which is equal to switch is on. So switch is on means 0 to dt minus I0 into C into dt. So here we will get V minimum minus Vmax which is equal to minus I0 into C into dt. Okay, after integrating. Okay, we know that del V is equal to Vmax minus V minimum, means change in capacitor voltage is Vmax minus V minimum. So del Vc, so here sign it will become plus because here it is V minimum by minus Vmax. So when we are making it as Vmax minus V minimum, this will become plus. So del Vc is equal to D into I0 divided by Fc. Here you can see in the case of boost converter, del Vc, change in output voltage, ripple in output voltage is directly proportional to the duty cycle. Okay, here change in output voltage del Vc or change in capacitor voltage del Vc is directly proportional to the duty cycle. Also change in inductor current del I which is directly proportional to duty cycle. So here in this case output ripple voltage or output ripple current will be maximum when D is equal to 1. Understood? When D is equal to 1 only we will be getting maximum output ripple voltage and maximum output ripple current. So this is all about boost converter. In boost converter it will be it is a step up chopper, that is output voltage will be always greater than input voltage. So these all are the expression, means expression for the output voltage V0 equal to Vs divided by 1 minus t. Then inductor current IL equal to I0 divided by 1 minus t. Then ripple current expression del I equal to D into Vs divided by FL. Then ripple voltage or capacitor voltage, ripple in capacitor voltage or ripple in output voltage which is equal to D into I0 divided by Fc. Okay. So these all are about the boost converter. Okay.